Hi, hello, how are you? My name is Anna Benzel. Welcome back to my channel. We are going through as many LeetCode problems as we can, and we are on question number 87, the scrambled string. So I completed this one yesterday, about 13 hours ago, and it took me a significantly long time. So again, the solutions that I'm doing in this particular problem pass through are all done in Python. So let's go ahead and look at my submission before we jump into the question, because the first submission I did not get accepted. It exceeded time limits, and I did have to reconfigure the code that you see here. And I can show you that, which did get configured for about an hour, as you guys can kind of see. So overall, I really loved this solution. The second time around, I think I did need that time, that hour, to really hash out what was going on. But the runtime for this beat 78% of users who use Python, and the memory for this beat 71% of users who use Python. So again, definitely like this solution and love that it worked, but it did take me a long time. Some of these hard problems, I don't know if you guys face this. Like this one's a little bit wordier, which I think is probably why it was a little bit harder for me, but some of these hard problems are not hard, and some of these hard problems are like the hardest thing I've ever done in my life. And we've had a couple of those. So let's just go ahead. I'm going to go ahead and read through this problem here. If you guys want to skip it, you can read it at your own time, but I just want to jump in here. So we can scramble a string S to get a string T using the following algorithm. 1, if the length of the string is 1, stop. 2, if the length of the string is greater than 1, do the following. Split the string into 2 non-empty substrings at a random index, i.e. if the string S, divide it into x and y, where s equals x plus y. Randomly decide where to swap the 2 substrings or keep them in the same order, i.e. after this step, s may become s equals x plus y or s equals y plus x. Lastly, apply the step 1 recursively on each of these 2 substrings x and y. Given 2 strings s1 and s2 of the same length, return true if s2 is a scrambled string of s1, otherwise return false. So these were the examples that they gave us down below here, and these were the constraints. So kind of a wordy problem and a lot of moving parts. But I just tried to do basically just that. I did a recursive approach based on dynamic programming, because that's what I'm most comfortable doing. If you guys have seen my previous videos, DP is like it for me. That's my kryptonite. So we start off here with the helper function, which is a recursive function that takes 2 strings. And in this case, it's S1 and S2, and the memo dictionary. So this function just determines whether S1 and S2 are scrambled versions of each other. That's pretty much it. But before we're starting the recursive exploration, the function checks to see if the pair S1 and S2 are already in the memo dictionary, and if it is, it returns that previously computed result. This felt pretty unavoidable to kind of optimize for this redundant calculation, and I think what contributed to the overall improvement of the time complexity of this. So then going into if the characters in S1 and S2 do not have the same frequency, which in this case it's denoted as counter S1, meaning counter S1 is not equal to counter S2, then the function cannot be scrambled versions of each other, and it's just returned as false. So if S1 and S2 are identical, then the function then returns true. So the 2 identical strings then are considered scrambled versions of each other. So if the above conditions, this is where the else comes in. If the above conditions are not met, the function then enters a loop to explore possible split points, which is denoted by k within the strings. So the recursive calls are going to be made based on 4 different scenarios. The first scenario is we split both S1 and S2 at the position k and recursively check both sides. Number 2 is the split at S1 at position k and S2 at position k and recursively check both halves. Then we split S1 at position k and S2 at the end and recursively check both halves, and then we swap that again with the 4th option, the S1, we check the end, and S2 at position k. So if any of the recursive calls come back as true, it means that there is valid scrambling that is a possibility, and the function sets memo S1, S2 to true and breaks out of the loop. So if none of the recursive calls end in a valid scramble, then the function memo S1, S2 is then false, and we store the result in this memo S1, S2. So I tried to do this as straightforward as possible. I think DP for this is a very common approach. If I wanted to challenge myself, I think I would try to explore other methods that could have been better. But again, I'm not mad about my solution. The first solution obviously wasn't great, but this solution is fine. Like, I like it. Could it be better? Everything could always be better. Everything can always be improved. But I'm not going to redo it, but this is just future thoughts, because I know I'm going to be going through a lot of LeetCode problems, and just knowing that I did something I was really comfortable with instead of something I'm not comfortable with. The whole reason I really want to do this is to become comfortable with things that I'm not comfortable with. So next time I get something like this, which they do usually have these suggestions of like related stuff somewhere. I don't know, maybe they don't. Maybe the editorial has something. Maybe not. Sometimes they have like people in the solutions will talk about like, this is similar to this problem. And I do want to find problems similar to this and push myself and challenge myself in those ways. But this code is available in the GitHub repo. Link down in the video description below. You guys go ahead and fork it and clone it. Make it better. Make it worse. Have some fun. Learn something new. And I will see you guys in the next video. Goodbye.